Alright, so in this video we're going to learn about something called vertex form, how to write a quadratic equation in vertex form. And it's somewhat similar to what we did in an earlier section. We were talking about, let's say, slope-intercept form versus point-slope form versus standard form, just different ways of writing the same equation. We're used to seeing this. We're used to seeing things in standard form, which looks like ax squared plus bx plus c. And normally when we're solving an equation, it equals 0. In this case, it's equal to y, but the same reasoning applies. Vertex form looks like this. Y equals a number a, which by the way is the same value as that a. And then this right here represents completing the square. It's a perfect square that we've kind of made ourselves by completing the square. And the nice thing about vertex form is it's very easy to find out what the vertex is. The h and the k are going to stand for numbers, and we'll see what that looks like when we actually do a problem. But as an example, suppose that our equation was y equals 2 times x minus 3 squared plus 4. That's an example of something in vertex form. The vertex right here would be 3, because 3 is what makes that parenthesis 0, and 4, because when this whole thing equals 0 and we add 4 to it, that's where we get that 4 from. So it's very easy to tell what the vertex of something is when we put it in vertex form. So how do we do that? Well, there are four main steps to it, maybe a couple sub steps, but the four main steps are we're going to move this c number. They're going to give us an equation in standard form, like you can see in numbers 1 and 2 at the bottom. We're going to put this off to the side, the c value. We'll factor out the a, and then we'll complete the square and finish by factoring. Then we'll have our answer in vertex form. So let's see how that's done. So the first thing, this is really almost the same as completing the square. The difference is that we're going to try to keep everything on the right side of the equation. When we're solving something by completing the square, normally that doesn't equal y, it equals 0. So there's no problem moving things over. In this case, we're going to try to keep everything on the right side. So the first thing is this number is not going to factor, so let's just move it kind of off on its own, so to speak. So I'm going to put this over here so it doesn't get in the way. Normally we would move it to the other side. We're just going to leave it alone for now. Okay, our next step is to factor out the a, if there is an a. And in this case, a is equal to 1, so we don't really need to factor it. In number 2, we will have to pull it out, but in this case we don't. Okay, so that's not going to get in the way. Now we need to complete the square, so we take half of the number in the middle, so negative 16, half of that is negative 8, and then we square it, and squaring negative 8 gives us positive 64. Okay, now here's the thing. Normally we would add 64 over here as well to balance things out. But in this case, like I said, we're trying to keep everything on the same side of the equation. We're trying to keep everything on the right side. So here's how you can think of it. Plus 64, pretend that you stole $64, right? You did the wrong thing, you steal $64, and now you feel guilty, you want to give it back. If you add $64 to your bank account and you want to balance that out, the way to balance out a plus 64 would be to take it away again, would be minus 64. So if you add something here, you have to take it away right here. If you subtract something here, you would add it back right here. All that we're doing in this case is we are balancing out the effects of what we just did, so that the net effect, think about it this way, what's the net result of adding 64 and then subtracting it? The net result is nothing, and that's okay. That means our equation is balanced. Okay, now the very last thing we can do is we can now factor this. This is a perfect square. That's going to be x minus 8 squared. Where did minus 8 come from? It came from half of this number. And then negative 64 plus 59 is negative 5. So this right here is now in vertex form. And the vertex of that parabola right there is equal to, what makes that 0? What x value makes that 0? It would be positive 8. And then when this whole thing is 0 and we subtract 5 from it, we would get negative 5. We already know from earlier that we can find the vertex by using negative b over 2a. That's right here. So let's verify that. Let's do negative b over 2a. So negative b would be negative 16, which is positive 16, over 2 times a. And a is 1. So 16 over 2, that does equal 8. And then if we plug 8 in right here, 8 squared minus 16 times 8 plus 59. 8 squared is 64. 64 minus, that's 128, would be negative 64. Negative 64 plus 59, sure enough, it does equal negative 5. So that's just an interesting way to see that there are two different ways of writing the exact same equation. They come in handy in different cases. If you want to know the vertex very easily without having to plug in negative b over 2a, obviously having it in vertex form is nice for that. Okay, number 2 is a little bit trickier, so try this on your own. See if you could pause it. The only extra step is that negative 4 in front of x squared has to be factored out of the negative 4x squared and the negative 32x. So see if you can do that, and when you're ready, press play. Alright, so let's give this a try. So our steps are going to be the same. We will start by moving this negative 58 over, and then remember that the a value has to be 1, and right now it's not. So the way that we can make that happen is we can pull out the negative 4 from these two terms, not from negative 58, because remember we're not dealing with that, we're just leaving it alone. So we'll divide each of these by negative 4. Negative 4x squared divided by negative 4 is x squared. Negative 32x divided by negative 4 is positive 8x. Why did we do that? Because remember we're trying to complete the square, and we can only do that when this number in front of x squared is 1. So now we're in a position to complete the square, so let's take half of this number, which is 4, and we will square that to get 16. Now here's where a lot of people make a mistake, so I want you to think about this carefully. A lot of people would say, well, since I just added 16, I'm going to balance that out by subtracting 16. And the reason we did that in the other problem is because we didn't actually do this step right here. We didn't pull out any negative 4. Okay, but in this case we did. So if you look at it carefully, we didn't really just add 16. What we really did was we added 16, but this negative 4 is getting distributed to it. So negative 4 times 16 is actually negative 64. What we actually did to this equation is we actually subtracted 64 from it, not added 16. And again, the reason is because the 16 gets distributed to this number in front. So the question is, how do we balance out a negative 64? What's the opposite of negative 64? And the answer is plus 64. That's how we would balance it. So now we're almost done. We just have to clean this up a little bit. So 64 minus 58 would be plus 6. And then this is a perfect square in the middle. This thing right here, it's x plus 4. Again, the plus 4 comes from half of that number. Now this is in vertex form. So try to think about the answer to this question. What's the vertex of this parabola going to be? We know, by the way, it's going to open down because of that negative in front. The vertex is going to be what makes this 0 right here, and that's negative 4. And now that this whole entire thing is 0 and we add 6 to it, we would get 6. So the nice thing is when you're trying to graph this and you have it in vertex form, we have the vertex. It's at negative 4, positive 6. So let me see, did I count that correctly? I think so. So there's the vertex. We know it's going to open down. All we need to do is just pick a point to the right and to the left of that. So let's just do that real quick. So we have negative 4. Let's pick negative 3 and negative 5. So if we plug in negative 3 right here, okay, negative 3 plus 1 is, negative 3 plus 4 is 1. 1 squared is 1. 1 times negative 4, negative 4. Plus 6 would be 2, and that's going to be 2 also because it's symmetrical. So we'll have points at negative 3, 2 and negative 5, 2, and that's what our parabola is going to look like. Sorry, the line was not very straight there, but that's how you would end up graphing it. So that's how to put something in vertex form. Hopefully that makes some sense.